Good afternoon, everybody. My name is Gary Gereffi. I'm the director of the Center on Globalization, Governance, and Competitiveness at Duke University. It's great to be at this conference, and I want to thank up front the partnership that really has allowed us to create this report. Environmental Defense Fund has been very instrumental in a series of projects we've been doing on the environment at Duke. And the 4 labor partners we had in this project have been extremely helpful as well. What I'll be describing, along with Marcy Lowe, one of my colleagues, is a bit about how the report got put together and what we're trying to do. Let me just say at the outset, what this manufacturing climate solution study was premised on was the idea that there are very strong links between clean technologies and US jobs, or between the green economy and the so-called real economy. Everybody sort of feels that's the case. We wanted to try to show how we could demonstrate some of those links. The report itself has 3 main authors, myself, Marcy, and Christy Dubé, who's also in the audience with us. And we worked with teams of researchers at Duke. I know right now this has, I think, gone through 2 printings and it's sold out, but it's available on various websites. So if you were to just type manufacturing climate solutions into a web browser, it would either take you to an EDF website or a Duke website or some others where you can download this. So what I want to do is I'm going to give you an overview, and knowing that this room is long and the people in the back aren't going to be able to see details of slides, what I want to emphasize is the kind of approach we brought to the technologies we looked at in this report. We looked at 5 specific carbon reducing technologies and their connections to US jobs. We're also working on 4 or 5 new technologies, and you'll hear something about one of those from Marcy when she speaks. So at the center we have at Duke, the Center on Globalization and Competitiveness, one of the things that unifies a lot of the projects we work on is that we think about globalization in terms of global supply chains. And I think in terms of showing the environmental connections or environmental impact of clean technologies in US jobs, this is a very, very useful tool. On the slide there, I've got a kind of graphic depiction of one supply chain we had used in looking at the IT industry, but it's just to show the features of this kind of supply chain analysis. If you look in the middle, we've got a set of boxes that go from raw materials on the first column, through components in the second column, through finished products, let's say in the third column, these are all color-coded in that case, through distribution and final consumption. The point of this kind of supply chain analysis is partly to show all the different links that are involved in making final products, many of which we're not really aware of when we just think about a computer, an automobile, a shoe, or an LED light, which is one of the things we're looking at. Now, connected to the kind of supply chain analysis in the middle, which is, let's say, tangible goods, going from raw materials through to finished products, we've also got on the top of any supply chain a set of services that are connected to that. These can be R&D, design, logistics, finance, et cetera. And we also have a set of supporting industries. And when we put these different elements together, we call this a value chain. And I'll try to give you some ideas. But one thing to keep in mind, why is this useful today? I think there's 2 features of these kind of supply chains that have dramatically changed in the last 2 or 3 decades that are key for us. One is offshoring, and the other thing is outsourcing. If we looked at an industry like the automobile or computer industry back 2 or 3 decades, a lot of those industries were located in particular countries, and they were carried out by vertically integrated manufacturers. We have 2 big changes that make these kinds of value chains far more complex today. One is the production's become globalized. It's done in lots of different countries. And 2, these industries have become fragmented. Lots of different firms are making different parts of a final product. So in carrying out this kind of analysis, that's part of what we've been trying to focus on. So when we use this kind of value chain analysis, we feel it helps us in several ways. One, it gives us a big picture of markets, supply and demand. We're not just looking at a final product, but all of the inputs that go into it. So one of our feelings about these studies is they've shown us a lot of so-called hidden opportunities for job creation connected to clean technologies that you would only see if you saw the whole supply chain. Two, we add on to the supply chain different layers of information. As you'll see in this kind of study, we're able to say in different boxes of a chain how many firms there are, how many workers there are, what the average wage of the workers are, and we can add in all kinds of information, including how much value added is there in different parts of the supply chain, which parts are most profitable, which parts are the ones that are focusing on cost cutting. That's helpful. From a point of view of strategy, all the discussion we're hearing now about policymakers wanting to try to figure out how do we create green jobs, we need to know what are the leverage points in these industries. So from our point of view, this is a really useful tool both for policymakers, but also for companies that are trying to figure out whether they should invest or not and what kind of strategies they should follow. And one of the things we also try to emphasize are leverage points. What are the real points of change in these different technologies? So in the report that that was sort of already shown to you, this one that we began with, we did 5 technologies, 5 clean technologies or carbon reducing technologies, which are listed up there. And one of the aspects of this set of technologies is we wanted to get technologies that represented a range of products. Some of these are relatively mature products, like auxiliary power units to reduce the idling in long distance trucks, or even the high performance windows. Some are relatively high tech, certainly LED lighting, concentrated solar, and others, this hog waste treatment that we call the super soil system isn't even commercially available yet, but it's on the cusp of becoming commercially available. So we wanted to take technologies that were new and old, that have different kinds of competitive advantage in terms of the US economy, and that's one of the things we try to lay out. So what I want to walk through in the next 4 or 5 slides is in every one of the chapters dealing with those 5 products, we have a set of visual displays that help us understand what's going on in that industry. And I want to give you a sense of what those are. And let me also say up front, besides the 5 technologies I just mentioned, we're currently working on another 4 or 5 that are very exciting because they're central to the stimulus package that we've been hearing a lot about. Waste heat recovery is one of them, and Marcy Lowe will tell you a little bit about that. Carbon capture and storage is another. We're working on hybrid drivetrains. We're looking into wind power, heat pumps. So there's a set of other new technologies that this same methodology could help us understand. So for every one of the technologies, and this is beginning with LED, light emitting diodes, that's one of the key products we looked at. We try to provide some sense, some visual sense of what the technology entails. And so in all of these cases, we've had to do a sort of layperson's market analysis that would try to explain in fairly explicit terms what we're talking about. In a light emitting diode package like you have displayed there, the little, let me see if I have the little brown box at the top, this might not work for, right there, that's actually a semiconductor chip. That's the high-tech part of a light emitting LED package. But all around it are a set of other materials that are needed for these LED lights, which have lots of manufacturing possibilities in different parts of the economy. And so what we're seeing in technology after technology is some high-tech parts and some much more conventional parts, which all go together and create manufacturing opportunities. For every one of our technologies or products, we try to show the relationship between key components and the raw materials that go into the components. So think back to what we were saying before, what I was saying before about a supply chain. A supply chain for any product starts with raw materials that feed into a set of key components or parts, which then become sub-assemblies which go into a finished product. But that finished product is in the middle of the supply chain. Once you've got a finished product, you have to distribute it to the final consumer. And one of the things we've discovered is that critical sources of demand or drivers of these supply chains are located in the post-production phase. So in all of our technologies, we've tried to show what kind of raw materials are used and where those raw materials come from. In general, what we're trying to accomplish in all of these studies is what is the US footprint for every one of these clean technologies in terms of US jobs, and what's the potential for expanding the US footprint? And so here we try to indicate where things are done. When we extend the supply chain further, we've got the raw materials on the left in the green, the components as the second column, the finished product as a third column, and then the end use. I think it's really critical in looking at all of these clean technologies in terms of figuring out what's their job creation potential to link supply and demand. Critical question is, how big is the market for all these technologies? And that's a big part of what our research has gone into trying to determine. What's the market for LED lights? What's the market for concentrated solar? And one of the things we've discovered is you've got to make a big difference between original equipment manufacturers or the new use of those products versus the replacement market or the retrofit market. So if we look at something like high performance windows, a lot of the market for those is in using high performance windows in housing that's being improved in terms of the quality of the insulation. For the auxiliary power units for long distance trucks, in the past that's been done as a replacement part or an add-on part after the truck's done. Now increasingly that's being incorporated into the design of the original truck. So I think if we're trying to figure out how big is the potential for manufacturing in these technologies, we really want to know not just what's the size of the market now, but what might be the size of the market and who's driving market size. One final factor, government regulations are extremely important, or government standards, in determining the size of the market. A company like Energy Star is actually coming up with stricter requirements for high performance consumer products, which would increase the demand for things like high performance windows. So as government regulations become stricter, the demand for the market size for these clean technologies is going to grow. And so that's part of what we've been trying to estimate in these studies. For every one of our technologies, we've wanted to put them on a map of the United States and try to figure out where are the primary manufacturers of these products in the US. And every one of these products has a different geographic footprint. They're spread widely across the country, but in different kinds of states. In this case, we have the location of top US window manufacturers, but that's the end manufacturer. If we think again about supply chains, the job creation potential is much broader than this because the parts that go into the windows can be made elsewhere. So I think one really useful way to think about these studies is from a state perspective. If you're a state, you say which parts of these supply chains are located in our state and how might we be able to grow those parts of the supply chains. When you get into, this is again a more complex version of the LED lighting value chain. And remember I said that our value chains are layered. We start out with relatively simple structures of the chain and then we try to add in more and more information. One of the key things that comes out in this LED lighting value chain, which is a fairly high-tech industry, is that the drivers of the chain, the companies and the parts of the chain that are actually determining how fast it's going to grow are located in different parts of the industry. If you look under finished products, we have some key companies in product design that are important drivers, some companies that are involved in marketing that are important drivers, and even in the distribution side, big box retailers, like whether Walmart is going to actually use LED lighting, which it did in all of its stores, or other big retailers are going to be sources of demand, or the government is going to be a source of demand, become really important in understanding who's driving change in the industry. So I think if we think about an industry that has lead firms, or a supply chain in terms of lead firms, the question is who's got the power to push the chain in certain directions? And we try to make that fairly clear in each of our studies. We then want to also provide a sense of global competition. So again, in something like LED lighting, some countries like the US and parts of Europe, Germany and the Netherlands in particular, and Japan are very well established global leaders in the industry. Other countries like the UK and Italy are very important in the design part of the industry. Other countries are the low-cost production centers like China and other parts of Asia. So it's important to realize that a US map alone only gives us part of the picture. It tells us where some of the production for these clean technologies are taking place in the US, but we're in competition with other countries. So we're trying to give us a sense of both the global picture and the national picture. Now, a question that's come up frequently in the discussions about clean technology is how many jobs are in this sector and how big of a demand are there for clean technology jobs? And one of the numbers that's been utilized a lot in the campaign was 5 million jobs. Some others say 3 million jobs. But these are sort of aggregate estimates using a variety of assumptions about how many clean technology jobs might be out there. Underneath any big number like 5 million jobs or a $1 trillion bailout, there's all kinds of questions about what's inside. How's it really put together? So we've taken a different approach to the jobs question, and we're trying to look at it from the bottom up rather than the top down. We want to go to these actual industries and then be able to break down for every stage of the supply chain how many jobs are being created in the different boxes, who are the companies that are creating the jobs, what states are those companies located in. So one thing I need to sort of just highlight, if you see it put together neatly as a supply chain, you'd say, well, that's pretty straightforward. I can see how the end product has all of these different components. You cannot find virtually anywhere this kind of a map of the market. That's one of the things we realized in starting this research. It's incredibly painstaking to create the linkages. But once you understand the linkages, you have a much better sense of the spillover effects of these clean technologies. And so I think that's one of the ways we've hoped to sort of contribute to this discussion is we can actually identify where the jobs are located in different parts of the chains. Well, it's who's doing what where, and what's the long-term advantages of this in terms of the US. And so I'm just going to close with a couple of slides on what this means for US competitiveness, and then I'll turn it over to Marcy for a peek at some of the newer work we're doing. But I think US competitiveness here really means low carbon competitiveness. In one of the plenary sessions earlier, Tom Friedman's new book was mentioned, and his idea that we're moving from an era when information technology was a driving force to an era where energy technology is a driving force. I think he's absolutely right. There's tremendous potential in that. But to seize that opportunity, the US really has to think about us being in global competition for low carbon leadership. When we've looked at that question across our different case studies, we've found different answers about where the US is positioned in terms of these different technologies. In a case like concentrated solar, the US is out front, but in fact, you look at it, and there's 4 different contending technologies in concentrating solar. There's a trough system, a tower system, a dish system, and a lineal Fresnel system. But that's what we're developing. Spain's developing a set of technologies as well that are also very important. Germany is doing it for areas where you've got less intense light. So there's lots of global competition, and I think part of what we need to be aware of is what's happening on the innovation front and who are we competing with? Because it's not just a production story. It's also very much an innovation story. One of the real opportunities, I think, for the US to take leadership is in some of the waste areas. North Carolina happens to be the #2 hog farm producer in the United States. We're second to Iowa, and there's this little map. The dark states are the ones that have the largest number of large hog farms, and the lighter states have fewer numbers. But one of the big issues in hog farm is what do you do with the hog waste? It's a tremendous environmental problem, and I think something like 25% of carbon emissions actually come from livestock. And North Carolina in 1997 created a moratorium on these open pit lagoons, which is how they had dealt with hog waste. And so one of the 5 technologies we study here is something called super soil systems, which is a really innovative way to treat hog waste. If we can bring that to commercial market, the US will have an enormous lead, not just in hogs, but in other kind of livestock production. So I think we need to look at non-traditional sources of innovation. How do you take something like hog waste and come up with a clean technology that can actually become a global leader? Another example is LED lighting. You'll hear more about this from Marcy, but one of the key companies, the most innovative companies in the world, is actually located in Durham, North Carolina, where Duke University is located. It's a company called Cree. Cree burst onto the sort of world scene through the Beijing Olympics. They actually sold something like 750,000 of their LID packages to the Beijing Olympics for the bird nest and the overall, the aquatic center, I think it was. And those were all manufactured in Durham and exported to China. Cree's now got big contracts with the Pentagon. So these are areas where we can have homegrown innovation. Last slide for me, it's a quote up there that says, will US technology leaders be able to bring costs down before the lower end Asian manufacturers can bring performance up? It's a quote from a Department of Energy technology consultant, Morgan Patterson. I just want to say that I think that might be framing the question somewhat in the wrong way. Asian countries, a whole set of Asian countries are definitely production leaders in many of these clean technologies. They're the cheapest subcontractors and they're making very sophisticated products. But they're not content to stay just being good producers. They clearly see the advantages of innovation themselves. They're trying to move up the value chain from being low-cost production leaders to doing a lot of the R&D work that's going to create the next kind of technology innovation. I think the challenge for the US is exactly combining innovation with high-quality production. We can't keep those two separate. We can't assume we can be the innovation leader and somebody else will be the low-cost production leader. So the US has to find ways to maintain its innovative edge, but also through linking it much more closely with a variety of kinds of production capabilities we have and skills in our own workforce. And I think that's the tremendous potential in these clean technologies or low-carbon technologies. So with that, let me turn it over to Marcy Lowe, who will just give you a few more ideas about some new work we're doing at the center.
Great. I'm Marcy Lowe, and I'm a research associate, colleague of Gary and Christy. And I would just like to follow up what Gary just shared about sort of the larger takeaways that we got from studying these 5 technologies, and also lead into some even more exciting findings that we're coming across in the further, the upcoming chapters that we're researching for this project. It's up to me to do that, isn't it? There we go. One big takeaway that we have obtained from doing this research on green jobs and these technologies that have the potential to reduce carbon and carbon equivalent is that once in a while, not in every industry, but if you study enough industries, once in a while you will come across a firm in an industry that is truly innovative in its vision for the industry in which it's positioned. And these companies are special in that they go ahead and educate and advocate way beyond their own company's interests and for the whole industry, and or maybe even for the whole country or the environment, the whole world. We've come across several of these companies and I'd like to introduce them to you. One striking thing is that in addition to maybe having a publicity department, these very competitive companies have almost what I would call a think tank department that does policy analysis and really looks at their company's position in the wider world of events. They're companies that are very innovative, and so obviously they have a lot of proprietary information that they protect fiercely, and yet they know when it's okay to be open source and when in fact a forward-looking 21st century business will look to open source as a way to lift its whole industry and make things better for everyone. And they don't jealously guard all information just in case it might help their competitors. So one of the firms that we came across in this research that really fits that description is Cree, which Gary just mentioned. Those lights are from the bird's nest in the water cube. They're modeled after soap bubbles. And that was kind of playful for the water cube. Each one of those bubbles can withstand the weight of a car. They're very sturdy. Literally, there are millions of LED chips in those venues from Cree. Originally, the Olympics, the designers had put fluorescent lights up and they didn't like how they looked. And so they took them all out and ordered, this is what I find just the beauty of this, is that they're Chinese, right? And they ordered these. They took down those products and ordered these LED lights that were manufactured in Durham, North Carolina. And I just thought that was kind of a neat little twist. Cree is one of these examples of these innovative companies, and again, sort of a think tank kind of company that has this vision, I think, for the wider industry. Chuck Svoboda, the CEO of Cree, has been quoted saying that they're not just building their company, they're building an industry. And of course, the lighting industry, dominated by the 3 big lighting companies in the world stage, is based on the light bulb. And fluorescent bulbs are a light bulb too. And LED lighting is based on a semiconductor industry, so it's really quite different. For a company like Cree that has really learned how to make the highest quality chips that these lighting products are based on, I think that you can make an argument that they make the highest quality ones in the world for general lighting purposes. You know, the kind of nice warm light that you can read by and has a nice quality to it. That's sort of the holy grail of LED technology, and Cree has it, and they literally have PhDs running their equipment, so they know that they have to jealously guard their proprietary information, and yet we have called them a lot in our research. They're very, very generous with information. They partner with DOE all the time. They've done tremendous R&D and shared, sort of shared that. In other words, they aren't so afraid that their information will help their competitors that they won't share what will help everyone. Another company that fits this category is called RED, Recycled Energy Development in Westbrook, Illinois. And this takes a little bit of explaining. Oh, I got ahead of myself. I'm going to talk about recycled energy, and there's one subset of recycling energy that is called waste heat to power. And the idea is in a big manufacturing facility, like say an iron smelter or a big petrochemical factory, they heat their kilns to like 7,000 degrees Fahrenheit, and then that process, that very heat-intensive process, gives off a lot of exhaust heat, and that's just vented to the atmosphere, but it actually contains a great deal of energy. Well, you can harness that heat, generate electricity on it, using it, and then you can use that electricity in the same factory, the same iron smelter, or what have you, and you can sell the excess to the grid. And this is an amazingly, it has huge potential, but it's largely untapped. This is kind of a new way of looking at getting more efficiency out of our energy sector. And just as an example here, you have a great big steel smelter on the left, and then you have some solar panels in a field of wildflowers on the right. Which is cleaner? Electricity that's produced by recycling the waste from this big gray, ugly steel smelter, or the electricity that's produced by solar panels? Does anybody know the answer? Which is cleaner? They're both equally clean. If you generate electricity from that waste heat, you are not adding one drop of additional fuel, not one bit of natural gas or coal or anything to generate that electricity. It's every bit as clean as the electricity generated from solar or wind. And this is what Recycled Energy Development, this company in Westbrook, Illinois, is trying to educate us on. And they are testifying in hearings. They've really weighed in on the recovery package. They're really trying to get companies also to realize that they can save a ton of money. The CEO of this company, Tom Caston, is a former CEO of a company called Primary Energy. They run a series of these projects in a steel smelter called ArcelorMittal, which the Mittal Corporation is, of course, a very large steel producer. They generate 220 megawatts of electricity in this series of projects recovering and recycling energy. Tom Caston, the CEO, likes to mention that in 2004, when this smelter project was cranking out 220 megawatts of clean electricity, that exceeded all of the electricity produced by all the grid-connected solar panels in the world at that time. So it's really worth looking into, and we're doing a supply chain on it. It's a forward-thinking, a forward-looking thing. One question that RED likes to ask is, one sort of myth that they like to bust is that if this is such a good idea, then why aren't more people doing it? Or if companies could save so much energy doing this, why don't they? Because for this example, on the steel smelter, they save about $100 million a year in energy costs. And so Tom Caston says, it's not true that if it saved so much money, then everybody would already be doing that, because our regulatory policy is what prevents it. And literally, an entrepreneur who tries to do one of these projects in many, many states cannot really make it feasible purely because of the utility regulations. So a lot has got to change in order to make this feasible. I'd like to go back now to the one that, thank you. Infinia. This is a neat company that's setting up to produce concentrating solar technology, and it is actually, Infinia has designed a technology that it has intended from the beginning to manufacture the technology purely with auto manufacturing capacity, tier 1, tier 2 supplier auto manufacturers that are disused in the current slump. We have about capacity to produce about 19 million vehicles. We're only using about 15 million worth of that capacity, and Infinia has figured out a way to use that capacity and retooling and use those same workers, same skills, same everything to produce these concentrated solar powered dishes. This is a really exciting new development, and they're about to make a major announcement very, very soon, so I would look for that. This is my final slide, and then I'll turn it back to Melissa. All three of these companies that I just mentioned are going to be here tomorrow in a panel called Business Case Studies. It'll be in the Hoover Room. It's workshop number 45 tomorrow morning. You get a chance to meet folks from all three of these companies. Thanks.